Welcome to the third episode of The Late Show Online with Jim Buteau, your host. My guest today, Morgan Liberty, CNC programmer and board game fanatic. Yeah.
Fanatic, I like it.
Fanatic.
I like it either way.
Hi.
Hi.
CNC programmer, what does that do?
Basically, any parts that you would need to make any kind of assembly function. So let's say the engine block in your car goes. It explodes because you're driving like a fucking idiot. Something. I'm not a car guy. But it fucking goes. Well, you got to buy a new engine block or you got to buy a new part. You need replacement parts. So in most cases, those parts have to get machined, specifically if you're making it out of any kind of metal. What I do is make those parts, or at least create the programs to make those parts. Let's stick with the engine block example. I take a drawing and then I would determine what I need to do to a piece of material to get that finished part from start to finish. So I go from having a big fuck off block of aluminum to a finished engine block that's getting installed in your car. So that's the gist of it. And obviously it's not only car parts. I've worked in medical, aerospace, nuclear, and like really basic stuff like the mining sector. And the only real difference between those types of parts when we're machining them is your tolerances. So for instance, if you're going to make a drill bit that's going to go 600 feet down and just break some rock, well, they don't care really what the dimensions are because it's just a piece of steel that's going to slam into the ground.
And then so the machine does everything, right? So you set up basically a machine that creates it. So
Yep.
Everything's automated?
Yeah, everything's automated. At least when it comes to CNC, everything's automated. You have manual machining, which a lot of people think is really a thing of the past, but depending on the job, you can get somebody to manually work on a lathe or a mill and create parts just fine. But when you're doing large volume and you need consistency, that's where CNC machining comes in.
So that's a branch of engineering, right?
Yes and no. It's certainly lower level engineering because I don't have to make any of the decisions as to how to make sure that this part works. I'm really just following guidelines set by an engineer. So an engineer would create a drawing and then stamp the drawing, and it would be verified by other engineers to say, yes, this drawing represents the finished part that we need, and all the specifications and requirements to make sure that that part will do the job that's required of it. What I do is I look at all that information and I need to know what each of those requirements and standards are to ensure that we are following them. You still do need a human operator. So that person would take my program or whoever's program and they download it into their machine, and then they'll have a set of setup instructions. Basically, it's telling them which tools they're using and how to set up those tools. And as long as they've set those tools up properly, put those tools into the correct spots within the machine, and they're there when they run the program the first time. It's what we call proving out. And you basically run the program a little bit slower and make sure it's doing everything it's supposed to do, because these machines move quite quickly. So if you leave a machine running at 100% and you take a program that's never been run before and you just load all the tools and you go, yep, let's go. Everything's good. The guy gave it to me. Perfect. Not my problem. It could very quickly become your problem in a very loud and exciting way, because those machines, they don't necessarily give a shit what they're cutting or where they're going. If you tell, like, so here's your basically machine table. We'll put it right down here at the bottom of my screen. So the machine can't go any lower than this. But if I put into the computer, if I tell it to go 6 inches below rock bottom, and it has the travel to do that, theoretically, it will do it. So you could very easily take a $1 million machine and just drive it into itself. So it's a little nerve-wracking when you're first getting into it, especially when you're first starting to create programs, because like what I do is I'll create a program and then I prove it out.
Yeah.
But there are times, and you create a program and somebody else proves it out. So now, if you miss a decimal place, or you just weren't thinking and you miss something, or the software you're using to create the program doesn't simulate properly, what'll happen is somebody else is going to have a really bad day, but they'll be very happy to come tell you about it. So making sure everything's perfect, you'll make a lot of friends. But if you're just kind of like typing things in and firing out a program, and you're like, yeah, the simulation ran, the part looked fine, you're going to piss off a lot of people, and you can break a lot of tools.
So is that the part that excites you a little bit about the work? The fact that you have to deliver a certain standard of, it's not just repeat every day, do the same thing. It's not like you're making the same bolt over and over and over and over again, right? You're always working on new projects and stuff.
You're absolutely right there. So I have an issue where I can get bored very easily. And I enjoy solving problems. And if there's no problems to solve, then I'll get bored and I'll go find a problem to solve, which usually is either a waste of time or it complicates somebody else's life, and then they fucking hate me.
What's the coolest thing you ever worked on? Like the coolest thing you've crafted? See, that this is the part where you sell your job and you say, "I've worked on a spaceship," or I built a reactor for Elon Musk.
I didn't build anything for Elon Musk that I know of. I have worked on a few parts that have gone into rockets, but they're like small, like couplings and shit like that. So nothing super exciting.
I'm going to cut that part out. I'm just going to be like, I've worked on rockets. Cutting the rest out.
I built rockets on my fucking manual lathe. I've worked on a couple really cool things. Some are cool because they're like complicated, and others are cool because of like how they're used. So for instance, earlier on in my career, I was working on cooling rod holders for nuclear reactors. The previous company I worked at did some work for Canadian nuclear companies. Fairly basic parts, but like really tight tolerances. And the whole idea was it was basically a disc with a whole fuckload of holes, maybe like 100 holes just in this disc. And you had to make these two discs so they would fit perfectly together. And the idea was these cooling rods would be slotted into each of the holes to hold the cooling rods in perfect position. So you had like a grid. And if there was any kind of deviance, it could really fuck the whole thing up. So it was really tight tolerancing. So yeah, it sounds like, oh, Morgan made a plate with holes in it, which, yeah, if you're looking at it, it's a plate with holes in it. But at the time, it was really cool because it was for a nuclear reactor. Something I've worked on more recently is just large. It's not going to sound cool. It's cool to me because it's a really big block. It's like a big block. Like for me, it's big. But they're like 10 inches by 12 inches by 10 inches. But there's a lot of very deep holes in this block, and there's a lot of features. And this is later in my career where I'm working now, where I'm kind of acting more as a jack of all trades.
A jack of all blocks.
Jack of all blocks. You need a square? I'll make you a square. Super nice. So when I started off, when I was in school, I had a manual machining course. And I was I picked up machining quite quickly, and I enjoyed working with my hands. I enjoyed working with metals and getting cool finished parts and knowing that you did everything to make that. And the first time you see like a piece of steel and you are just like ripping material off of it and like making a cool shape and something, even if it's just something functional, something that you need, it's just cool seeing that happen. And it's a little dangerous at first because you're getting like hit in the face with like metal chips and they're burning your skin. You're like, ooh, exciting. Until you get like pretty serious burns because you're a fucking idiot and you touch metal. So you learn that nice and quick. That's day one.
This field could be for someone interested in engineering that doesn't really want to, I guess, go through with the whole master's in engineering.
Well, no, that's actually what got me into this field. So the program I went into, basically the idea was, hey, come here, do a 4-year college program, learn the basics, learn the hands-on, learn what you need to physically make a part. And then you can go to our partner university and do less years there. we'll take the 4 years of college you've done and we'll say it counts as 2 years of university. So you can get your college diploma, which is your fundamental, your hands-on, your practical experience. Then you can go get your theory. So instead of spending 8 years in school, you can spend 6 years in school and get 2 diplomas, or a degree and a diploma. So that was the whole reason I went to college first. I was like, well, I'll do that. I like the hands-on side of things, and then I'll go to university. Then I realized after I finished with college that I really didn't want to go to university, because I saw what was involved more on the engineering side of things. And I realized, like, as much as it's kind of interesting to me, I shouldn't say kind of interesting, it's very interesting, like being able to not just create a part based on a drawing, but design a part, create the drawing, and then send that out or create it myself. That's very interesting. It's very exciting. And if anything, I would actually recommend anybody who wants to get into engineering, that's a very good way to go about it, because those types of programs still exist.